In design, we talk about wicked problems as inherently messy, complex, and without any single answer, only better or worse solutions. We also talk a lot about how any solution to a wicked problem will inevitably cause other problems. So a core perspective for designers has to be to try to find the best solution that will also cause the least future harm. In our work, we use mapping and visualization to better understand the complexity of wicked problems in the built environment. And we're specifically interested in how many of the invisible systems, for example, social, economic, and political systems, impact the people who live in those environments. We believe that to design better solutions for today, we need to understand the history of a place and the context of a problem. And we found that mapping and data visualizations are one of the most effective tools in our research to do just that.
Sara and I use mapping in our work because it is a very powerful tool to make the abstract concrete and to connect meanings and concepts. So to help us explain what we mean by that, we want to unpack some of the powerful functions of maps with a few examples. First, maps measure place. When trying to understand the context of a wicked problem, it is very important to understand that context with multiple measures. These rich screen-printed maps are of the Mississippi Delta and are complex and take some time to decode. They include many different types of information typically missing from platforms like Google Maps, such as a planting calendar, a historic photo, changing river paths. And this information helps us understand the place not just as a physical location, but also as a cultural landscape impacted by seasonal cycles. The second function of maps we find powerful is that maps isolate information to show relationship. In these maps of the Boylan neighborhood just east of campus, the creator replaced typical map information like roads and buildings with social interaction information. The map on the left shows the number of times a household was mentioned in a newsletter, and on the right, which houses had jack-o'-lanterns on their porch for Halloween. You can see a correlation of density of mentions and lanterns, a shared pattern that might have been obscured if the map contained lots of additional layers, like in the aerial photo. Looking at the two maps together helped the creator understand a relationship, possibly a hierarchy, that wouldn't have been apparent with just one view.
The third function of maps, which helps to create meaning, is that maps have scale. In these maps, a portion of the lower Mississippi, infamously called Cancer Alley, the map creator documented the size of chemical spills by layering concentric circles and the density of the population in the area through aggregating human figure icons. She uses this graphic information to emphasize the proximity of people to toxic sites and to imply the cause of elevated health impacts like cancer in these communities. The fourth critical function is that maps frame and orient. Consider the map you've grown up seeing versus these maps known as one continent and one ocean. In the map we're used to, the Atlantic Ocean is centered with the Americas and Europe near the middle and Asia the furthest away. These spatial relationships are and were framed by political power and orient cultural perspectives about places that are closer and more similar versus farther and more different. So it's important when working with maps that we acknowledge that they are not neutral and that they can influence our interpretation of data and that they reinforce our biases. The fifth function of maps is that they can represent visible or invisible phenomenon through shapes, colors, lines, and icons. The creator of this playful map has encoded different sources of smells with color-coded dots, and then encoded the territory, intensity, and directionality of that smell as it moves through the breeze, through concentric lines and distorted shapes. Through this map, we're invited to imagine a unique sensorial experience of Edinburgh missing from a typical map.
And the final function of maps we want to discuss is that maps are narrative. Maps tell stories, and they can tell many different stories. They engage the viewer in creating meaning, and we call these thematic maps. This map shows Napoleon's march on Moscow, and you might remember that Napoleon's march was not successful, in part because the troops set out late in the year, got caught in the winter weather, and were forced to retreat. Here, the orange line is the path of attack, leaving France and marching eastward toward Moscow. And the black line is the path of retreat from Moscow back to France. The width of the line is proportionate to the number of soldiers alive during that part of the trip. You can see the black line is very thin at the end of the retreat as compared to the width of the orange line at the start of the attack. If you overlay this map on a geographical map of Europe, it spatially aligns, but the only spatial information the map maker has included here are the rivers. And he added a line chart along the bottom of the map showing how the temperature dropped as the troops retreated. The reason for isolating the rivers as the only geographic information is to emphasize that when the path crosses a river and the temperature drops, we see a sharp decline in the number of troops due to hypothermia.
Hopefully these examples have made a case for why maps and visualizations can be very powerful tools when integrated in the research process, especially for the study of complex wicked problems.
We believe that maps are constructs of reality, and that means that when we are making them, they are creating a view of reality that will impact how we understand the world as a result. That is a really important weight. And one of the ways that we handle this weight is to use the map as a means to raise questions and test hypotheses, not to state an unequivocal fact. In our video about Confederate memorialization, we'll walk you through how we applied this process to our research. Additionally, our colleague and former student Britt Davis takes a similar approach in order to examine the impacts of coal ash runoff in and around North Carolina.
If this discussion of maps gets you excited, many disciplines on campus integrate mapping into their curriculums. Architecture and landscape architecture, design studies, graphic design and communication, geography and geospatial analytics, and data science. Additionally, data visualization is important to almost every discipline, and you will likely find ways to use maps in most fields of study across campus.
Thank you so much for your time. Come and visit us over in the College of Design.